All right, how many carbons do we have on the left side?
3.
How many hydrogens do we have on the left side?
8.
And how many oxygens? How many carbons on the right side? How many carbons on the right side?
1.
How many hydrogens on the right side?
2.
How many oxygens?
3.
Okay, and as long as all your products are carbon, carbon dioxide, and water, it'll always be 1, 2, 3. All right. So what are we going to try to balance first? Carbon. So let's put a 3 here, and that'll give me 3 carbons, but it changes the number of oxygens. So I now have 6 oxygens here. 3 times 2 is 6. Plus 1, that would be 7 oxygens. Okay? All right, I've got 8 hydrogens on the left side and 8 on the right side. Okay? This is not one that's going to work out to be an odd number. So let's see, we need a 4 here. That would give me an 8. So that's 6 plus 4 is 10. Okay, and so all we need is a 5 here to get 10, right? That makes sense? Okay, let's try this one. C4 H10. Notice in the combustion reaction, I always list water, the product water, as a gas. Brian? Notice I always list water as a gas in the product of a combustion reaction. Why would that be? Yeah, when you're burning something, it's hot. You're making steam. Okay? All right, let's do our grid here. Are you doing this with me? Okay. So this is a case where we have an even number of oxygens on one side and an odd number on the other side. For some reason, this seems to stop a lot of students cold in their tracks. And they'll get to a test and have something like this, and they won't finish the problem. And it's a real simple solution when this happens. Really, really simple. Okay? You need to go through, and except for the coefficient in front of the oxygen, you need to multiply all the coefficients by 2. Since there's an implied 1 in front of this species, we're going to put a 2 here. Since there's a 4 here, we're going to change that to an 8. Since there's a 5 here, we're going to change that to a 10. We're going to go back and recount everything. This is a 4, by the way, not a 9. Okay, so now we have 2 times 4 are 8 carbons. We have 20 hydrogens. We didn't change the number of oxygens, so that's going to stay 2 for the moment. Over here we now have 8 carbons. Okay, we have 8 times 2, or 16 oxygens here, plus 10 oxygens here, so we've got a total of 26 oxygens at the moment. Okay, 26. All right. So now all we have to worry about is how do we get this oxygen to have 26? Oh, I didn't do the hydrogens yet. So 2 times 10 is 20. Okay, so how do we get the oxygen? Well, that's an even number now. This is easy. You put a 13 in front of it. Okay?
No, not to multiply everything by 2.
What?
How do you know not to put a 2 in front of that?
In front of the oxygen? That's one way to think about it. Another way to think about it is I said so.
So like you always do it? Only when you have an odd number.
Yes, this is something you do only when you get to a situation where you've got an odd number of oxygens on one side and an even number on the other. Yes.
Does that ever happen with anything other than oxygen?
Not very often, and it happens so little I don't worry about with the other things, but it happens an awful lot with oxygens, especially with combustion reactions.